Hi, welcome to Basic Math. Today we're going to look at some applications of percents. So we'll do some story problems. We'll probably talk about taxes or like sales tax, not income tax, sales tax, and maybe some commissions, but let's get started. So when we do a percent application, we want to take the time to set the problem up properly. The biggest mistake I see when people do percent problems is that they're in a hurry and they think they know what they're supposed to be doing. Because really these all boil down to you're either going to end up multiplying or dividing to get your answer, but that's only 50-50. And so we want to make sure we can do this properly. So first, identify the pieces. If you haven't had a chance to watch my video on just basic percent problems, go back and watch that video. I'm going to reference it here throughout this one, but identify those pieces. What is your base or whole? What is the percent? Do you have that? And then what is the part or the amount? And then after that, set up the equation or proportion. Take the extra little bit of time to set it up. Doing that ensures that you can get the problem right. Okay, so don't just be in a hurry. It doesn't take long to get it set up. It doesn't take long to solve it, which is the last step here. So make sure that you do that. And then ask yourself one more question, which I didn't put on the board here. Does your answer actually seem reasonable and make sense? Because if you get an answer that's a little bit wacky, that probably means something went wrong and you should probably go back and look at it again. So let's take a look at my first example. In a shipment of parts, 3% are known to be defective. If 15 parts are defective, how many parts were shipped? And you can see I did all the work down here, but let's look at the problem first on its own merits. First of all, I noticed that we have the percent, right? We have 3%, so I get that right off the bat. You'll see that I chose to set this up using the percent proportion instead of the equation, so I just put my 3 over the 100 because that's the percent half of the proportion. So now that leaves us with this 15 parts. We have to decide if that's the whole or if it's the part. And in this case, it's not going to be the whole because these are the defective pieces. They're not all the parts that were shipped. Okay, all the parts that were shipped are going to be the whole thing, whereas this 15 is going to end up being just the part. So I set up my proportion with the whole on the bottom. Remember that, and I don't know that, so I use an X. 15 goes on the top. Now I can cross multiply. 3 times x gives me 3x. 15 times 100 gives me 1500. Divide both sides by 3, and I get an answer of 500, which seems reasonable, right? We have this number of parts that were defective. Our answer should absolutely end up bigger than 15, and probably quite a lot bigger because we're only looking at a 3% defective rate. So there you go. There's our first example. Let's do some more. Okay, so here's our next problem. If 45 people are enrolled in a math class, but only 35 finish the course, what percent finish the course? And on this one, we're going to end up rounding this one. So let's round it to the nearest tenth of a percent. Okay, so on this one, we don't have the percent. We know that that's something we don't know. But we do need to identify the whole or the base number because that's going to allow us to set up, in this case, I use the equation. The whole or the base is the 45 people because that is all of the people in the class, whereas the 35 are just the people who finish the course. So when I came to set this up, I have my percent that I don't know, x, times the whole, 45, is equal to the part. I divide both sides by 45 and I get this lovely repeating decimal, 0.7, and it just goes on forever like that. Now I want to round this to the nearest tenth of a percent. But first, I have to slide this decimal point to the right because I don't want to round it to the tenth place yet. I want it to be the nearest tenth of a percent. So I take my decimal point, slide it 2 places to the right. That's where I get my 77. And then since I'm just going to have a line of 7s, that next 7, which isn't on my board, will round the 7 that is there up to an 8, giving us 77.8%. So really, if you can identify the pieces and get this set up, these solve really pretty quickly. So please, please, please be careful. Take the time to do it. I just can't stress that enough. The biggest problem I see, and I know I've said this like 3 times already, the biggest problem, hands down, is people are just like, oh, here, let me just try multiplying these numbers and see if I get the right answer. And it just doesn't always work. So take the time to set it up. All right, we're going to move now into sales tax. So let me get a new board. All right, so now sales tax. With sales tax problems, the original price is going to be our base for the whole thing. The sales tax, which is what we're going to be trying to find in this problem, will always be the part. So that's really nice. And then the sales tax rate is going to be given as a percent, and so you'll always have that. All right, so on this problem, it says a pair of shoes costs $45. If the sales tax rate is 6%, find the total amount needed to buy the shoes. All right, now this one's a little bit tricky. I shouldn't say tricky, I should say it's a little bit sneaky. Because notice it wants to know how much you actually need to buy the shoes. So hang on to that thought for just a second. So we have a sales tax rate at 6%. We know the original price of the shoes. So I can find the sales tax by setting up my problem. Here's my sales tax rate as a decimal. Remember, you have to use, if you use the equation, the percent has to be changed to a decimal. So we have 0.06 times 45, and that's equal to X, which is my tax. When I multiply, I get 270, and so the sales tax here is $2.70. And this is where you're going to have to watch out and be careful, because that's not actually what this problem asks for. Right? This problem asks for how much money do you need to buy the shoes. You don't need $2.70. You need the $45 for the shoes plus the $2.70 for the tax, giving us a total of $47.70. So there you go. That's a sales tax problem. If you just remember that the price is the base and the sales tax is the part and the tax rate is always going to be your percent, you'll be all set. Again, just like I said about the previous example, please make sure that you take the time to set it up. It's really important, okay? Because again, a lot of times people are in a hurry and then things go wrong for them. All right, we have one more problem to do in this section. We're going to be looking at commission. So give me just a minute. All right, so for our last example, we have a commission problem. Commission problems are where you have somebody, in this case we have a realtor who's selling a house, who makes what's called a commission off of a sale. So that's just a percentage of the selling price that ends up going to, in this case, the realtor. So these are very similar to sales tax problems. It's just that instead of paying the government a tax, it's like you're paying the realtor a tax, except it's not a tax. Anyway, excuse me. Again. So here we have it. A realtor makes a 4% commission on each house she sells. If her commission is $3,600, how much did the house sell for? All right, so we have a problem. And again, we have to figure out the part, the whole, and the percentage. In this case, the percentage is straightforward. It's just that 4% commission. You'll notice I'm using the proportion, so I put 4 over 100. For the rest of it, I have to ask myself, is this $3,600 commission, is that the part or the whole? Well, the whole here is going to be the selling price. Remember I said this is just like finding a sales tax. So the selling price is the whole thing, just like when we bought that pair of shoes in the last example, the price of the shoes was the whole thing. So we don't know that, so I used an X. That leaves the commission to be the part, and I put that on top. I cross multiply, 4 times X is 4X. Here, move over here. 3,600 times 100 is 360,000. But then we divide both sides by 4, and we end up with $90,000 for the price of this house. So there you go. That's some basic percent applications, some sales tax and commissions. These really aren't too bad, but please, again, for like the 800th time in this video, please make sure you take the time to set them up. If you do that, they will go well for you. If you don't, you're going to run into problems sometimes. So just be careful. Thanks.